Alright, in this video today we're going to be looking at one-step equations that have kind of more special circumstances. And the first one we're going to be looking at and talking about is one-step equations with fractions. So, if you see equations with fractions, specifically a fraction being multiplied by a variable, then to get rid of that fraction that's being multiplied by a variable, we're going to multiply by the reciprocal. So, you should remember from a long time ago, or if not, we're going to get a little refresher, that if I take two reciprocals, I'm going to get and multiply them, I'm going to get an answer of 1. Let's look at an example. If I have the fraction 1/2, the reciprocal of 1/2 is 2 over 1. Well, if I multiply these, 1 times 2 is 2, 2 times 1 is 2, and 2 over 2 is equal to 1. So if I multiply a fraction by its reciprocal, I get an answer of 1, which is going to allow me to go ahead and get rid of a fraction being multiplied by a variable. Let's go ahead and look at an equation where this is happening. So if you take a look, this equation says 2/3 times x equals 10. So we're going to do what we have been doing, which is we're going to go ahead and draw our fence. And I need to get rid of this fraction being multiplied by the variable x. So to do that, I'm going to multiply both sides by the reciprocal of 2/3. Well, the reciprocal of 2/3 is 3 over 2. Remember, whatever we do to one side of an equation, we're going to do to the other side. So now that I have it set up, I can go ahead and do the math. You should see that 3 times 2 is 6, and 2 times 3 is 6, and 6 over 6 is just 1. So the reciprocals here kind of cancel each other out and become 1. Well, 1x, or 1 times x, is just x. So now that I have my x isolated, I can bring down my equal sign, and now I need to multiply this side. Well, I need to turn 10 into a fraction. So now that I have that, I can multiply it out. Remember, we multiply the numerators and we multiply the denominators. 10 times 3 is 30. 1 times 2 is 2. And you should see that 30 over 2 is really just 30 divided by 2. And 30 divided by 2 is 15. So I get x equals 15. Remember, you can always substitute 15 back into the equation to make sure it works. Let's take a look at another situation. In this problem, we have -6/5 times k equals 12. So again, the first thing I'm going to do is I'm going to draw my fence. Now, to isolate my variable, I'm going to multiply the reciprocal by the reciprocal of 6/5. The reciprocal of 6/5 is 5 over 6. Now here's the catch. Because this is a negative fraction, I have to multiply by a negative reciprocal. So whatever I do to one side, I'm going to do to the other. So what you should notice on this side is that we have a negative times a negative. And using our tic-tac-toe board, real quick, let me just bust that beauty out. I can see that a negative times a negative is a positive. And remember, reciprocals multiply down to 1. So now I have a positive 1 times k, which is really just k. I'm going to bring down my equal sign, and now I'm going to go ahead to the other side. I'm going to put 12 over 1 so I can multiply this out. I'm going to go ahead and take care of my negatives first. A positive times a negative, positive times a negative, is a negative answer. Now I'm going to multiply my numerators. 12 times 5 is 60. 1 times 6 is 6. And then right here, I see 60 divided by 6 is really just 10. So I get k equals -10 as my answer. So those are examples with fractions. Now we have some equations where we can see some of those special rules that we learned about integers pop up. So let's go ahead and take a look at this one-step equation. It says x plus 3 equals -7. So again, the first thing I'm going to do is I'm going to draw my fence. I have plus 3, and I need to get it away from x. So I'm going to do the opposite or inverse operation of addition, which is to subtract 3. Well, whatever I do from one side, I'm going to do to the other side. My 3's create a 0 pair, and I'm left with just x on the left. On the right side, though, we have negative 7 minus 3. Now, Miss Keelan and I have been talking to you guys all year about direction arrows, and they're still really, really important. I have a negative 7. Negatives move to the left. I'm subtracting 3. Subtracting moves to the left. When my arrows and my signs are the same, I'm going to add and keep the sign. 7 plus 3 is 10, and I'm going to keep the sign, which is a negative. So I get x equals negative 10. So again, if you need to, you can substitute it back in to see if the answer works. Let's look at a few more. So in this case, I see an equation 6 equals x plus negative 11. First thing I'm going to do is I'm going to draw my fence. And you might notice in this problem that the x is on the right side instead on the left side. And that's okay. Now here's where some of you might overthink this, and you just got to keep it simple. I have plus a negative 11. In this case, I'm not going to use the idea of inverse operations as much as I'm going to think about how do I create that 0 pair. If I have a negative 11, what's the opposite of a negative 11? A positive 11. Whatever I do to one side, I'm going to do to the other side. So now I have a negative 11, a positive 11, that makes my 0 pair. They cancel each other out, and I am just left with my x. So I'm going to bring the x down, I'm going to bring the equal sign down, and I get 6 plus 11, which is just 17. Now you can leave your answer like this, but if you want to rewrite it, so x equals 17 like that, you're more than welcome to, whatever you're more comfortable with. Let's take a look at one more, and then we are done. So I'm going to draw my fence, and then I'm going to check out this equation. It says x minus negative 14 equals negative 3. Now, your little alarm bell should be going off in your head. We have double negatives. Before I can do anything, I need to get rid of that double negative. So remember, double negatives make a positive. So now my equation says x plus 14 equals negative 3. Now that I have it all set up, I can go ahead and use my inverse operations. I have plus 4. The opposite is to subtract 14. Sorry, I think I said 4 back there, but you guys know what I mean. My positive and negative 14 make a 0 pair. I'm going to bring down my x, bring down my equal sign, and now I have to look over here at my adding and subtracting integer rules. So that means you better be drawing your direction arrows. We have a negative 3, which goes to the left. I am subtracting 14, which goes to the left. When my signs are the same, we add and keep that sign. 3 plus 4 is 7. Nothing plus 1 is 1. And I'm going to keep that sign. So I get x equals negative 17. So hopefully that walked you guys through some of those special circumstances, and you are ready to tackle some problems on your own. Thank you for dealing with me and all my little hiccups today in this video. I hope you're all having a really fabulous day.